Yes, so hello everyone. Sorry for this problem. I don't know what happened, but let's try to present. So my name is Xia Wang, and currently I'm a first-year PhD student at Stockholm University, supervised by Niklas, and co-supervisor is Gunnar. So my talk today is on monodispersed colloidal hydrochar assembly and templating. So the assembly with well-organized structure and its template materials are of great importance in terms of applications like catalysis, optics, and medicines, and so on. So for this type of assemblies, if the particles are monodispersed and well-organized, it's preferable because it can give more organized structure and more interesting. So for this type of organized structure, organized spherical particles, currently the studies are mostly focused on silicon oxide metals or metal oxides or polymers. But the assemblies of carbon spheres are not well studied yet, especially the hydrochar, like what we have talked a lot yesterday and also this morning. So we have studied hydrochar for many years till now, in terms of the synthesis, the chemical and physical properties, and also the applications. But we seem to not notice the colloidal property, the assembling behavior, and templating possibilities. So in this study, I started from preparing the solution of glucose hydrothermal carbonization, and then try to remove the excess glucose and other small molecules in this solution, and only leave the hydrochar particles and the water in this dispersion. Then we try to dry this dispersion in a glass wire, and to let this dispersion dry on a glass surface to obtain this hydrochar assembly. And then we use this assembly as a template to prepare a templated alloy via reactive infiltration of the copper silicon alloy with this hydrochar. And I'll give more details about this later. So for this colloidal hydrochar dispersion, the DLS results showed it's highly monodispersed with the PDI values of this. And also the particle sizes are centered at 140 nanometer with a very narrow particle size distribution range. And the zeta potential is quite negative. And with the repulsive and the attractive forces, the dispersion is very stable. And we tried with sodium chloride to destabilize this dispersion, and it turned out around like over 100 millimole per liter of the salt solution can destabilize this solution, this dispersion after like 2 days or 3 weeks, longer time. So with this assemblies formed along the drying direction on the glass surface, we took some pieces from the glass wires and tried to look at it on the microscope. It turned out all these pieces are like prismatic rods with very tidy edges and also smooth surface, which is parallel with the glass surface. And the two sides seem to be rough, but they are still like very well organized and consist of the particles of around 140 nanometers. And then we try to pyrolyze these rods to check the quality let's say, of the rods. And we pyrolyzed the material under 600, 800, and 950 degree, and all of them kept the structure of the original rods, and the spherical particles were still well organized, and the surface is still smooth. And then the nitrogen gas absorption measurements showed that the pyrolysis increased the specific surface area and porosity significantly. And as the pyrolyzed hydrochar has this 600 more square meter per gram specific surface area, and also the pyrolysis generated a lot of micropores in this rod material, and especially just in the spherical particles. And also the pyrolysis makes the spaces among the particles narrower comparing with the original hydrochar rods. So when it comes to the templating, it's similar with what Professor Vanessa talked about yesterday. But what here is different is that instead of the physical template, there is a kind of there is a chemical reaction happened during this templating. And so to be specific, I put one piece of the alloy above a bunch of hydrochar rods, and then put this mixture into like an oven with argon gas under this temperature. And so the hydrochar would pyrolyze during this procedure, and then at the same time, the pyrolyzed hydrochar would react with the melted alloy, and so its carbon atoms reacted mainly with the silicon, formed the silicon carbide on the surface of the spheres. And then inside the spheres is pyrolyzed hydrochar, and there were still some alloy left. And then after we obtained this alloy carbon composite, we try to remove the pyrolyzed hydrochar by calcination in air. And then we obtain this templated alloy with silicon carbide. So the XRD pattern showed that comparing with the original alloy, this alloy carbon composite showed an obvious peak of silicon carbide, and also some amorphous peaks here for the carbon pyrolyzed hydrochar. And after removing the pyrolyzed hydrochar, these broad peaks disappeared, and also the alloy is still here, and the peaks of silicon carbide are still here in this material. And the morphology check of the composite and the final templated alloy showed that both the composite and the final product kept the morphology of the rods, like original hydrochar rods. And in this composite, it showed clearly that there is one layer covering this hydrochar rods, hydrochar spheres. And after removing this hydrochar spheres, it showed hollow structure in both TEM and SEM. So this templating method worked with this hydrochar rods reactively infiltrated with this copper silicon alloy. So this is the study. And with this, I'd like to thank my supervisors and other collaborators who contributed to this study, and also the support from our group and our department. Also, thank you for GreenCarbon and university for all the support. And finally, thank you for all the audience today, and I'm looking forward to some discussion if you have some questions. Thank you. Hmm? Okay.
Okay, sorry, Xia. Thanks for your presentation. We have questions. We have time for a couple of questions. Questions, because finally the presentation of Felipe will be rescheduled to the oral session 5 tomorrow. So we have just time for 2 questions.
Okay.
We will see if there is any. Yeah, is one, and there is one question from.
Yes. Okay, I got a question from Vanessa, and it shows that the nitrogen absorption measurement started at relatively high relative pressure, difficult to give in the micro range. Or should start at least. Yes, I started my measurement from very low relative pressure. Yes, I think that's a good point. I think for the pyrolyzed sample, it didn't show this uptick, but these data are like when I plotted this data, I didn't add any like y-x values. So it's at least it's the original data here. Yeah, you are right. I think I should start from maybe a lower range to let it show the data here.
Okay.
Good question.
Seeing there is no more questions at the moment, I think the people was to want to drink a coffee or something. Huh?
Yeah.
So thanks, Xia, again for your
Thank you.